let's say you were given this equation. Well, not equation, this Ka value. And it was 3.8, right, times, as it often is with these Ka numbers, 10 minus 2. What would the pKa value be? And the pKa value, as we all know, is pKa is equal to negative log of the value of Ka. So the negative log of the value of Ka would be the pKa. So this will be written as negative log, now let me just adjust the paper here, of 3.8 times 10 minus 2. So how would you approximate this? So to approximate is what I usually do is I treat this negative 2, I bring it over here, so the power of negative 2. And I put it inside a bracket. And then from this value, I subtract the main number, that's 3.8. So subtracted by 0, you always have to put a 0 in there, 0.38. Now this 0 is not because of the power, it doesn't matter what power this is up to, I just always do that. So, and this will be equal to what's negative and negative over here, so these cancel out, so this will be positive 2 minus 0.38, and that value you could do in your head, but I'll just write it down here. 2 minus 0.38 will be something like 0.62, or not 0.62, but rather 1.62. This would be the pKa value, approximately 1.62. Now let's do another equation similar to this in fashion. So I'm just going to get rid of this paper now, and we'll start writing. So let's say you are given a hydrogen concentration of 1.5 times 10 to the negative 5. So the general equation we derived last time was m minus 0.n. And let's call this number over here n, and m will be equal to the exponent power over here. So the exponent power is 5. So, well, the negative of m, because this is negative 5, what you would have to, what you're interested in is 5. So you bring 5 over here, minus 0. And what's the value of n? Well, we already said 1.5, right? So 0.15. 5 minus 0.5 will give you, and just so we're all clear, the P of hydrogen ions, right? The power of hydrogen is the pH, right? So that's what we're trying to find. And the pH, as you all know, is found using this equation, negative log of the concentration of all the hydrogen atoms, right? Or rather protons. So the negative log of the concentration of the protons. So using this concentration, we're able to find the pH. So 5 minus 0.15 is 4.85. And so this shortcut really works really well where you don't have a scientific calculator handy. Maybe we should do one more example just so what I'm saying makes more sense. So the concentration of OH, let's say we're given it to be, let's see, 2 times 10 to negative 4. And from that, we're tasked with finding the pOH, or the power of the hydroxide. Let me move the earlier equations up, just so we have some more space to work with. Let me move this slightly to the right, so it's all visible. So the pOH will be the negative log of the concentration of the hydroxide ions, right? And we already seen using the m minus, this is an m, I'm sorry about this shoddy pen I have today, m minus 0.n, you're able to find the power of hydroxide. So what's m? Well, m is this exponent here. What is it? It's negative 4. But let's take the positive of that, the absolute figure, which would be 4. And over here, you'll be subtracting it by 0.n. And what's n in this case? Well, n is a main number, the bottom, the base, whatever you want to call it. And that'll be 2. So 4 minus 0.2. So approximately the power of hydroxide will be equal to, look at my funny approximately sign, it will be 3.8. And this will be approximately the power of hydroxide. And we did all this without using a calculator. So yeah, hopefully you guys find this helpful in your chemistry or physics, maybe approximations, or maybe even biology, because you know the Henderson-Hasselbalch equation, let's say. Yeah, but yeah, see you guys later.